Everyone, let's look at today's LeetCode problem. Count number of ways to place houses. There is a street with 2n plots, so this number is going to be 2n, and we are given with n plots. So there is a street, we are given with this number n, which means there are plots on either sides. So if there are 3 plots here, there are going to be 3 plots on this side as well. The plots on each sides are numbered from 1 to n. On each plot, a house can be placed. Now we want to return the number of ways a house can be placed such that no two houses are adjacent to each other. So if we put a house here, we cannot put a house here. The next house can only be placed here. Or let's say in this condition, if we put no house here, then we can either put a house or we can also decide to leave this empty. That's fine. So return the number of ways houses can be placed such that no two houses are adjacent to each other on the same side of the street. Since the answer could be very large, we can return modulo. And this also says that if a house is placed on ith plot on one side of the street, a house can also be placed on ith plot on the other side of the street, which means if a house is here, the other house could also be placed here, which means there is no restriction in terms of what could be placed on either side of the street. The only restriction that we know of is what can be placed adjacent to each other. That's the only restriction that we are given with. So let us see how we are going to solve this problem. So I'm going to take a case where we have 2 houses. So, or 2 plots rather. So if we have 2 plots here, we are going to have 2 plots here as well. So one thing that we can notice is that if we know the number of ways to arrange these houses on one side, or number of ways to put houses on one side, then both the sides are actually independent. So if the number of ways on one side is going to be x, number of ways on the other side is also going to be x, because the number of plots is exactly the same, right? So if we multiply both the numbers with each other, that's going to be our answer. So essentially, we just need to calculate the number of ways to arrange or put houses on one side of the street, and that will give us the answer for both the sides. So let's focus on just one side itself. Now let's take an example where we have 3 plots. So let me put 3 plots here, 1, 2, 3. Now at each of these plots, we can either put a house or we can decide not to put any house. So let's say that the state that we go in is I put a house here and rest of them remain empty. And in this case, I don't put any house at all. Now from here, we can go to 2 more states. So if I put a house here, then on the next space, this I cannot put any house. This has to remain empty, right? So we go to the next one, this one. So this I put a house. And in this case, I do not put any house. So this is what we are focusing here, right? Now in this case, again, let us see. So this is already considered. Now the second spot we are considering. So I put a house here, and in this case, I put no house. So because there was no house here, there was no restriction, and we could directly put a house in this case. What's the other possibility in this case? We have already considered all 3 positions, so this is done. Now let's look at this side of things. So we have a house here. Now can I put a house here? No, this has to remain empty. There is no other condition, right? And that means this is the only possible condition for this case. Now let's come to this side. Now we can either put a house here or we can decide to keep it empty. So these are all the states that we can come up with. This is 1, 2, 3, 4, and 5. So we have in total 5 states. And the 5 states come from 3 plots on one side, which means if we have 3 plots on both the sides, so this is going to be something like this, right? 3 plots on this side of the road, 3 plots on this side of the road. We have 5 arrangements for here. We have 5 arrangements for here. We multiply both of them and we get 25 as the answer. So if the value of n is going to be 3, our answer is going to be 25. So now that we know in principle how these states are going to be formed, let us see how we are going to solve this. And from these states, you would have assumed that the answer is going to be something related to dynamic programming. So now we have two states here essentially. One state where we put a house, so we have a house in one state, and in the other state we have no house, so we can also call it empty. Let's take the case where we have only one plot. So if we have one plot, we can either put a house here or we can put no house here, which means one state from here, one state from here, and the answer is going to be 2 for them. Let's take an example where we have not one plot, but we have 3 plots. And let's assume that we already know the answer for the second plot. And what do we know about this? We know the number of ways that this remains empty. And we know the number of ways that this remains not empty. So not empty, or I can also call it house case. Now we are concerned about this particular case, right? So what are the options here? One option where this remains empty and the other option where there is a house. Now what are the conditions where we can put a house here? We can have a house only when this is going to be empty. So the number of cases where this place is going to have house is going to be equal to the number of cases where this remains empty. So I'll just call it empty. Now the second case where there is nothing, so where this place is going to be empty. What are those cases? This can be empty when this place is empty, or if there is a house. So it doesn't care about them, right? So which means empty is going to be equal to empty of the previous state plus house. So this empty and house correspond to the number of cases where this place is going to remain empty and this place is going to have a house. So now the new empty is going to be empty plus house, and the new house for this particular case, new house is going to be empty itself. Now that we know the answer for the space 3, we should also be able to create an answer for space 4 if there were actually 4 houses. And finally, whatever the number that we get out of this is going to be multiplied by itself. So if the number is x that we get from here, we multiply it by x itself. So x squared is going to be our answer. Now, if you know what we are doing here in principle, we should be good to go to the coding pad, and let us see how we're going to solve this problem in terms of code. So I'm going to code this in JavaScript. Before we go to the recurrence relation that we discussed in the earlier section, we should also think about what the base case is going to be. So base case is where we have n is equal to 1. So what happens when n is equal to 1? So we can either put it in an if condition, or we can by default take both the states. So the first state was where the plot was going to be empty. So if it is empty, that is one combination that we have. And then the other case was where the house is going to be there. So that is another combination. So at the end, what we are going to output is going to be return empty plus house. Now that we are done with our base conditions, we should see what we are going to put in the recurrence relation. So let's have a for loop that starts at I is equal to 2. This is the case where I is going to be 1. So we only need to think about I is equal to 1, I is equal to 2, and I is going to go all the way until n. And at the end, we have I plus plus. So I tells you about the current state where we are. So now let's think what is going to be the case at I is equal to 2 state. What happens when we want to put a house at the current position? So if I want to have a house at the current position, the previous position needs to be empty. That means house in the current state is going to be empty itself. Now what happens if I want to have the current position empty? If I want to have the current position empty, that means it could be coming from the house state and empty state of the previous state. So house plus empty. Now because I have already overwritten house here, I rather want to keep it something like new house, and then at the end I can do house is equal to new house. So that should give us empty and house, both the states. Now as you can imagine, this number is going to grow very large and very early. So we want to do a modulo calculation here, and the value of mod is going to be 10 raised to power 9 plus 7. And because the final number is going to be not just empty plus house, but this is going to be multiplied by empty plus house, both of them, right? So I'll go to call it, let's one side combinations is going to be empty plus house. And if this is the case, then our final return value is going to be one side combinations multiplied by one side combinations. And this needs to be modded. Let's do that. Mod it with mod. But this number could be actually bigger than the integer length of JavaScript. So we want to convert this number into a big int, and this shouldn't be difficult. It is as easy as calling it a big int here. But we have converted this into a big int. We also need to convert empty and house, both of them, into a big int. So putting n at the end converts it into a big int, because all the calculations are going to happen between big integers only. So that should be it. Let me see, run the code. Yeah, this works. Let's try for a slightly bigger test case. It works. Let's submit it. Yep, looks like we have an answer. So that is all.